This video is not affiliated with, endorsed by, or sponsored by the National Institute for Automotive Service Excellence, ASE. It is created solely for educational purposes to help viewers expand their automotive knowledge and prepare for ASE-style topics. For official information, study materials, and certification details, please refer directly to ASE.
Hey everyone, welcome back to the channel. Today we've got something really helpful lined up for you. 50 practice multiple-choice questions to test your knowledge and help you study smarter. Whether you're brushing up for an exam, preparing for a certification, or just wanting to strengthen your automotive skills, this video is designed to guide you step by step. Grab a notebook, follow along, and see how many you can get right. Let's dive in and start learning together.
1. A truck with a 12V system cranks slowly after an overnight sit. Battery open circuit voltage is 12.55 volts. During cranking, the battery voltage drops to 8.8 volts, which is most likely A. Defective alternator, B. Weak battery capacity, C. High starter current from seized engine, D. Parasitic draw overnight. Answer: B. Weak battery capacity. Explanation: 8.8V under load is below the normal 9.6V minimum threshold at room temperature, showing that the battery cannot supply enough capacity despite having an acceptable open circuit voltage. 2. A 24V series parallel switch system intermittently fails to crank. With key to start, you measure 24V at the starter, but only for 0.2 seconds. Then it drops to 12V. What's the likely cause? A. Open armature in starter, B. Faulty series parallel switch contacts, C. Failed alternator rectifier, D. Open neutral safety switch. Answer: B. Faulty series parallel switch contacts. Explanation: the series parallel switch must hold the batteries in series during cranking. If the contacts fail, voltage drops back to 12V and the starter loses power. 3. Technician A says a voltage drop test across a cable should be done under load. Technician B says measuring resistance of a large cable with an ohm meter is the best way to find hidden corrosion. Who is right? A. A only, B. B only, C. Both, D. Neither. Answer: A. A only. Explanation: voltage drop testing under load reveals hidden resistance in heavy-gauge cables. An ohm meter cannot detect small but significant resistance in heavy-gauge cables. 4. On a J1939 network, a short to ground on CAN L typically causes which symptom? A. Both CAN lines read 2.5V, B. CAN H 3.5V, CAN L 0V, and bus won't communicate, C. CAN H 0V, CAN L 5V, but network OK, D. No effect, network self-compensates. Answer: B. CAN H 3.5V, CAN L 0V, and bus won't communicate. Explanation: a short to ground pulls CAN L down to 0V, disrupting the normal 2.5V bias and preventing data communication. 5. A 12V charging system shows 14.9V at idle with a fully charged battery at 77 Fahrenheit, 25 Celsius. Headlamps brighten excessively with RPM. What's most likely? A. Normal, no fault. B. Alternator undercharging. C. Failed voltage regulator, overcharge. D. Battery with high internal resistance. Answer: C. Failed voltage regulator, overcharge. Explanation: a proper voltage range is about 13.8 to 14.4V. Anything higher, like 14.9V, indicates the regulator is not controlling the alternator output.
6. A truck starter produces a loud whirring with no crank. Current draw is low. Likely cause? A. Shorted field coils. B. Worn brushes. C. Faulty starter drive, Bendix not engaging ring gear. D. Seized engine. Answer: C. faulty starter drive, Bendix, not engaging ring gear. Explanation. The starter motor spins freely, low current draw, but the drive fails to engage the flywheel teeth. 7. Which measurement best confirms diode ripple in an alternator? A. DC amps at B+ with clamp. B. AC voltage on battery with meter set to AC. C. DC voltage drop on ground strap. D. Ohms across stator with battery connected. Answer. B. AC voltage on battery with meter set to AC. Explanation. Excessive AC ripple greater than 0.3 to 0.5 volts measured across the battery indicates bad alternator diodes. 8. A customer reports repeated headlamp bulb failure. Charging tests good. You notice the headlamp ground is shared via a small rusty ring terminal. First action? A. Replace bulbs with higher wattage. B. Add series resistor. C. Clean/upsized ground and retest voltage drop. D. Replace alternator. Answer. C. Clean/upsized ground and retest voltage drop. Explanation. A corroded ground causes resistance, which can overheat bulbs and lead to premature failure. 9. An after-treatment NOx sensor heater circuit sets a high current DTC and blows its fuse. Which test is most direct? A. Resistance of heater to spec with connector unplugged. B. Check CAN for NOx messages. C. Measure O2 content in exhaust. D. Scope the PWM to the heater. Answer. A. Resistance of heater to spec with connector unplugged. Explanation. Measuring heater resistance directly confirms if the element is shorted or out of range, which would blow fuses. 10. A 7-way trailer connector intermittently loses clearance lights. Truck side output is solid. What's most likely? A. Open in trailer ground return. B. Short to power on brake circuit. C. Faulty alternator. D. Shorted ABS modulator. Answer. A. Open in trailer ground return. Explanation. Trailer lights rely on a solid ground connection. A weak or intermittent ground causes lights to flicker or fail even when power is present. 11. A DVOM on a good J1939 idle bus shows A. CAN H approximately 3.5 volts, CAN L approximately 1.5 volts. B. CAN H approximately 2.5 volts, CAN L approximately 2.5 volts with no differential. C. CAN H approximately 5 volts, CAN L approximately 0 volts constant. D. CAN H approximately 1.5 volts, CAN L approximately 3.5 volts constantly dominant. Answer A. CAN H approximately 3.5 volts, CAN L approximately 1.5 volts. Explanation. The CAN bus idles around 2.5 volts with the 2-volt differential between high and low. Typical readings hover near 3.5 volts high and 1.5 volts low. 12. A battery shows 11.9 volts OCV, then quickly rises to 12.6 volts after surface charge from a brief charge. Load test immediately passes. Next day, no start returns. Why? A. Sulfation or low capacity masked by surface charge. B. Parasitic draw only. C. Open cell would be 10.5 volts. D. Bad alternator diode only. Answer. A. Sulfation or low capacity masked by surface charge. Explanation.
A sulfated battery accepts surface charge but cannot sustain load for long. That's why it passes one test yet fails in real service. 13. What is the best method to locate a 300 mA parasitic draw? A. Pull all fuses at once. B. Clamp meter on negative cable and pull fuses one at a time after modules sleep. C. Measure battery OCV daily. D. Perform starter draw test. Answer: B. Clamp meter on negative cable and pull fuses one at a time after modules sleep. Explanation: a current clamp isolates parasitic draw without disturbing modules. Fuse-by-fuse testing pinpoints the offending circuit. 14. A Hall effect speed sensor versus a variable reluctance VR sensor. Which statement is true? A. Hall sensors generate AC. VR sensors need power and output square wave. B. Hall sensors need power and output square wave. VR sensors generate AC voltage with amplitude proportional to speed. C. Both require 12 volts power and output DC. D. Neither requires power. Answer: B. Hall sensors need power and output square wave. VR sensors generate AC voltage with amplitude proportional to speed. Explanation: VR sensors self-generate AC voltage. Hall sensors require voltage supply and output a digital square wave. 15. A power window circuit blows the fuse only when closing fully. Most likely cause: A. Short to ground in open direction lead. B. Seized motor or inoperant limit function causing overcurrent. C. Weak battery. D. Bad alternator. Answer: B. Seized motor or inoperant limit function causing overcurrent. Explanation: when a motor stalls at end of travel, current spikes. Without proper limit control, the fuse blows.
16. What does a high positive voltage drop, 0.6 volts, on the starter ground path during crank indicate? A. Normal operation. B. Excessive resistance on the ground side. C. Open solenoid. D. Shorted armature. Answer: B. Excessive resistance on the ground side. Explanation: a healthy ground path should show less than 0.2 to 0.3 volts drop. 0.6 volts signals corrosion or a weak connection. 17. Remote sense alternators improve charging by A. Reducing stator ripple. B. Measuring voltage at a distant bus and compensating for wiring drops. C. Increasing rotor current constantly. D. Eliminating regulator function. Answer: B. Measuring voltage at a distant bus and compensating for wiring drops. Explanation: remote sensing allows the alternator to regulate based on system voltage at the load, not just at the alternator output. 18. A truck with dual 12-volt batteries parallel has one battery at 12.6 volts, the other at 11.8 volts after rest. Best next step: A. Replace alternator. B. Replace both batteries as a set after charging and load testing. C. Replace only the low battery. D. Ignore, will equalize while running. Answer: B. Replace both batteries as a set after charging and load testing individually. Explanation: mismatched batteries stress each other. They should be tested individually and replaced together if one is weak. 20. A DMM shows 0 ohms between CAN H and CAN L with power off. Normal is about 60 ohms across the bus. What fault is indicated? A. Open in one terminator. B. Shorted twisted pair. C. No fault.
D. High-resistance splice. Answer: B. Shorted twisted pair. Explanation: normal resistance across the bus is 60 ohms. A reading of 0 ohms means the lines are shorted together. 21. What's the primary reason to use a current clamp with a lab scope on an injector circuit? A. See fuel pressure directly. B. Observe pentle movement via current ramp and detect shorts or opens. C. Measure battery SOC. D. Check O2 sensor function. Answer: B. Observe pentle movement via current ramp and detect shorts or opens. Explanation: the current ramp shows electrical and mechanical events confirming injector operation. 21. A no-charge complaint. B+ at alternator is 12.4 volts running. Field control duty cycle is near 100%. Likely cause? A. Shorted rotor causing overcharge. B. Open rotor or brushes or broken belt. C. Regulator commanding low field. D. High battery voltage. Answer is B. Open rotor or brushes or broken belt. Explanation: the regulator is commanding maximum field, but no output occurs. That means the alternator cannot produce current. 22. A 24-volt truck cranks, then immediately drops out due to ECM losing power. You find 24 volts at ECM KEOO, but during crank, ECM feed falls to 17 volts. Most likely cause? A. Normal drop. B. Weak batteries or undersized wiring to ECM, voltage drop. C. Shorted starter. D. Faulty crank sensor. Answer is B. Weak batteries or undersized wiring to ECM, voltage drop. Explanation: voltage dropping below the ECM's minimum threshold during crank resets the module. 23. A multiplexed body controller reports open left turn lamp. Bulb looks good. You measure 12 volts at socket with command, but lamp is off. Next step? A. Replace alternator. B. Check ground at socket and measure voltage drop on ground while commanded. C. Replace BCM. D. Reflash BCM. Answer is B. Check ground at socket and measure voltage drop on ground while commanded. Explanation: power may be present, but without ground, the circuit won't complete. A poor ground is the likely culprit. 24. What is the best tool to detect intermittent CAN reflections from improper termination? A. DVOM. B. Test light. C. Lab scope on CAN-H, CAN-L at 1 to 2 milliseconds per division. D. Ohm meter across CAN with key off. Answer is C. Lab scope on CAN-H, CAN-L at 1 to 2 milliseconds per division. Explanation: only a scope can reveal reflections and ringing on a high-speed data line. 25. A stop lamp switch has 4 wires, 2 for brake lights, 2 for cruise and ECM logic. Brake lamps work, but cruise won't cancel. Likely fault? A. Open in logic contacts within the switch. B. Short to power on lamp feed. C. Bad alternator. D. Burned bulbs. Answer is A. Open in logic contacts within the switch. Explanation: separate contacts exist for different functions. The cruise cancel side of the switch can fail independently.
26. A blower motor runs only at high speed. Cause: A. Open in-series resistor pack or failed resistor module. B. Shorted motor. C. Open high-speed relay. D. Blown fuse. Answer: A. Open in-series resistor pack or failed resistor module. Explanation: the blower motor resistor drops voltage for lower speeds. A failure bypasses all but high speed. 27. Technician A says PWM control is measured as duty cycle. Technician B says frequency changes when duty cycle changes. Who is right? A only. B only. C, both.
D. Neither. Answer A. A only. Explanation. PWM typically has fixed frequency, with the duty cycle changing to control output. 28. A headlamp relay clicks, but lamps do not light. You read 12 volts on load side with no bulbs installed. Voltage falls to near 0 volts with bulbs connected. Diagnosis. A. Short to ground downstream. B. High resistance or open in feed to relay or bad connection at load path. C. Bad alternator diode. D. Faulty ECM. Answer. B. High resistance or open in feed to relay or bad connection at load path. Explanation. Ghost voltage appears with no load, but collapses when current is demanded. 29. On a 24-volt system, what cranking voltage is a common pass threshold at 70 degrees F? A. More than 9.6 volts. B. More than 12 volts. C. More than 16 to 19 volts. D. More than 26 volts. Answer. C. More than 16 to 19 volts. Explanation. For 24-volt systems, the minimum acceptable voltage under load is roughly double the 12-volt threshold. 30. A relay coil measures 70 ohms. At 12 volts, what is its current draw? Ohm's law. A. 0.06 amps. B. 0.12 amps. C. 0.17 amps. D. 0.86 amps. Answer. C. 0.17 amps. Explanation. Current equals voltage divided by resistance equals 12 divided by 70, approximately 0.17 amps.
Temperature sensor reads colder than actual. What charging behavior results? A. Lower set point voltage. B. Higher set point voltage, overcharge risk. C. No change. D. Alternator off. Answer. B. Higher set point voltage, overcharge risk. Explanation. Regulators compensate for cold batteries by raising voltage. A false cold reading causes the alternator to overcharge. 32. A lab scope shows a missing tooth pattern on a crank VR sensor, but the amplitude is low at idle and the ECM sets a loss of sync code. Likely cause? A. Excessive sensor to tone wheel gap. B. Short to power. C. High battery voltage. D. Bad alternator. Answer. A. Excessive sensor to tone wheel gap. Explanation. A wide gap weakens the AC signal of a VR sensor, especially at low speeds, leading to ECM sync errors. 33. A glow plug control module sets cylinder 3 glow plug open. Which single test best confirms? A. Check battery SOC. B. Measure resistance of plug number 3 to ground with the harness unplugged. C. Check alternator AC ripple. D. Measure injector balance rates. Answer. B. Measure resistance of plug number 3 to ground with the harness unplugged. Explanation. An open glow plug will read infinity or very high resistance compared to the others. 34. A truck shows U codes loss of communication after an LED light bar was added. Bus errors increase when the bar is switched on. Why? A. Alternator undercharge. B. EMI or RFI from poor wiring or grounding of the accessory. C. Bad BCM. D. Faulty battery temp sensor. Answer. B. EMI or RFI from poor wiring or grounding of the accessory. Explanation. Cheap or poorly grounded LED accessories can inject noise into vehicle wiring, disrupting CAN communication. 35. Which reading indicates a properly terminated J1939 backbone, power off. A. 120 ohms, B. 60 ohms, C. 0 ohms, D. Infinity ohms. Answer B. 60 ohms. Explanation: the two 120 ohm resistors at each end of the bus combine in parallel, yielding about 60 ohms.
A two-speed fan clutch uses PWM to control engagement. With overheating, PWM duty cycle is high, but flange is slow. Likely cause? A. Bad ECT sensor. B. Mechanical clutch fault or low air supply if air-controlled. C. Bad alternator. D. Open can. Answer B. Mechanical clutch fault or low air supply if air-controlled. Explanation: since the ECM is commanding high duty cycle, the problem lies in the mechanical or pneumatic system, not the control signal. 37. A 12-volt battery cable shows greenish corrosion under heat shrink at the lug. Voltage drop on crank is 0.75 volts on the positive side. Correct repair? A. Clean terminal only. B. Replace cable or re-terminate with new lug and seal properly. C. Add dielectric grease over existing shrink. D. Ignore within spec. Answer B. Replace cable or re-terminate with new lug and seal properly. Explanation: internal corrosion increases resistance. The only fix is replacement or proper re-termination. 38. A technician back probes a connector with too large a pin and later the circuit is intermittent. Root cause? A. Connector pin spread or damage. B. High alternator ripple. C. Module sleep timing. D. Poor battery SOC. Answer A. Connector pin spread or damage. Explanation: oversized probes can deform female terminals, causing poor contact and intermittent faults. 39. A 7-pin trailer ABS lamp stays on. You confirm power and ground at the trailer ECU, but the wheel speed sensor resistance is half of spec. What next? A. Replace alternator. B. Replace sensor or check for chafed harness causing partial short. C. Replace trailer ECU. D. Ignore. Answer B. Replace sensor or check for chafed harness causing partial short. Explanation: incorrect resistance indicates an internal fault in the sensor or wiring damage. 40. A 12-volt system shows 13.2 volts with high electrical load at idle. At 1500 RPM, it rises to 13.9 volts. Battery light is off. Interpretation: A. Normal regulator behavior with load. B. Overcharge. C. Undercharge fault. D. Open field. Answer A. Normal regulator behavior with load. Explanation: it is normal for charging voltage to vary with load and engine speed as long as it stays in range. 41. A PTO interlock uses a clutch switch and part brake switch. PTO won't engage. Scan tool shows clutch pressed even when released. Most likely? A. Short to ground on clutch switch signal. B. Open park brake switch. C. Low alternator voltage. D. ECM failure. Answer: A. Short to ground on clutch switch signal. Explanation: a short forces the ECM to see the switch as constantly pressed, disabling PTO operation. 42. A truck has dim turn signals on one side with both front and rear glowing faintly together. Cause? A. Short to power. B. Cross-feed through a bad ground on that side. C. Overvoltage. D. Blown fuse. Answer: B. Cross-feed through a bad ground on that side. Explanation: without a proper ground, current flows back through other bulbs, making them glow dim. 43. Technician A says a scope with AC coupling removes DC bias to better see ripple. Technician B says DC coupling is required to view absolute voltage levels. Who is right? A. A only. B. B only. C. Both. D. Neither. Answer: C. Both. Explanation. AC coupling is good for highlighting ripple, while DC coupling is needed for true voltage levels. Both statements are correct. 44. A fuel pump relay control line shows 0% duty when commanded on. The relay never energizes. You jumper relay coil to ground and the pump runs. Likely fault? A. Open power to relay coil. B. ECM driver open or not grounding the coil. C. Seized pump. D. Short to ground on the control line. Answer. B. ECM driver open or not grounding the coil. Explanation. Since the pump works when grounded manually, the ECM control side is not switching the circuit. 45. A battery rated 950 cca tests at 720 cca on a conductance tester at 70 degrees F. Voltage drop at crank is 9.5 volts. But starts slow. What else could explain the slow crank? A. Alternator undercharge. B. High resistance in starter circuit cables or worn starter. C. Open cell battery. D. Parasitic draw. Answer. B. High resistance in starter circuit cables or worn starter. Explanation. Even with enough CCA, corroded cables or a weak starter can cause sluggish cranking.
46. While programming a module, battery voltage dips to 11.5 volts and flash fails. Best practice to prevent this? A. Disconnect alternator. B. Use a regulated power supply/maintainer capable of steady 13 to 14 volts during programming. C. Use a jump pack briefly. D. Lower battery SOC before flashing. Answer. B. Use a regulated power supply/maintainer capable of steady 13 to 14 volts during programming. Explanation. Stable voltage prevents programming corruption and failed flashes. 47. A body control fuse repeatedly melts but doesn't blow. The fuse holder is discolored. Root cause? A. Overcurrent. B. High contact resistance and heat at fuse terminals. C. Short to ground. D. Open circuit. Answer. B. High contact resistance and heat at fuse terminals. Explanation. Poor contact causes localized heating that melts plastic without blowing the fuse element. 48. An alternator with a decoupler or overrunning pulley causes belt chirp and charging fluctuation at idle. Pulley freewheels both directions. Diagnosis: A. Normal. B. Failed decoupler pulley. C. Shorted stator. D. Loose battery ground. Answer: B. Failed decoupler pulley. Explanation: a good decoupler locks in one direction and freewheels in the other. Freewheeling both directions indicates failure. 49. A chassis ground strap between frame and cab is missing after bodywork. Symptoms likely to appear? A. Overcharge. B. Intermittent sensor and lighting issues, increased can noise. C. Starter overspeed. D. No effect. Answer: B. Intermittent sensor and lighting issues, increased can noise. Explanation: without a proper cab-to-frame ground, circuits seek alternate return paths, causing electrical noise and glitches. 50. A technician measures 14.2 volts at the alternator B+ terminal, but only 13.5 volts at the battery positive post with high load. What's the best next step? A. Replace alternator. B. Inspect and voltage drop test the B+ cable from alternator to battery and repair as needed. C. Replace battery. D. Reflash regulator. Answer: B. Inspect and voltage drop test the B+ cable from alternator to battery and repair as needed. Explanation: the alternator is producing correctly, but voltage loss in the charge cable prevents full battery charging.
Thanks so much for studying with us today. I hope these practice questions helped boost your confidence and sharpen your skills. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you won't miss the next study session. You can click the links on screen right now to watch another study video and keep your learning going. I'll see you over there.